Hey everyone, this is Derek. In this video, we're going to look at composite functions. And what a composite function is when basically you have an inside function, you put something into it, it evaluates, it makes an answer, and then that answer goes into an outside function. So in a few less words, when the output of one function is used as the input of another function. So an example I use in class a lot is like, if you look at your grade book, some math has happened and your grade is sitting there showing as a percentage. But that percentage isn't really your course grade, it's your percentage. So that percentage goes into some more math and then that spits out your GPA. So the inside function would be the calculation to make the percent, and then the outside function would be the calculation to make the GPA. For composites, we have a couple of notations. F composite G of X, and this is, it looks like a degree symbol basically between there. And then this one is F of G of X. I generally prefer this one. We may run into that in the homework, so I'll show you both versions as we go. So we're going to look at two things. We're going to evaluate composites at a value, and then we're going to find the algebraic version. So sort of the same as we did in the last video, but this time with composition. So if we're going to evaluate G of F of 1, what we want to do first is evaluate the inside function using the input value or variable provided. So that's F of 1. So we'll find F of 1 down here, and we'll just toss a 1 in F. And it looks like F of 1 would be 1 and 6 would be 7, down 3 would be equals 4. And so then once I get 4, I put that back in right here. So F of 1 equals 4. So that means I'm going to find G of 4. So we put something into the first equation, or the inside equation, it spits out a number that goes into the outside equation, and that will spit out our answer. So then G of 4 will be 3 times 4 plus 1, or 12 and 1 for 13. Next one, same thing. This is just using the other notation. So G is the inside function this time, so we're supposed to find G of 0. So G of 0 would be 3 times 0 plus 1. So G of 0 equals 1. And then that goes into the outside function. So we're evaluating F of 1. And we just did that right here. So I already know the answer is 4. So I'll just skip down to the 4. So then for these next two examples, we're going to find F of G of X instead of F of G of a number. So this time we're going to evaluate one function at another function, essentially. So we'll start down here with F of G of X. So they gave us F and G up here in the directions. So notice that G of X is X plus 4, right? Because these things are equal. So if I'm finding F of G of X, that means I'm evaluating F at this function, or I could think of it as F of X plus 4. So if this is like F of 5, I would shove in a 5 into these X's and evaluate just like we did in the last ones. But here, instead of shoving in a 5, I'm going to shove in a X plus 4, because we're evaluating at the function rather than just a specific value. So that would look like X plus 4 and then quantity squared minus 3 and X plus 4. And then this is a spot where a lot of people mess up their algebra. They get X squared plus 16, and that is not true. So let me write this out side by side. X plus 4 quantity squared means the same thing as X plus 4, X plus 4. I'll go ahead and do this distribute here. And then we have to FOIL. So that'll be X squared. On the outside, we're going to get 4X. On the inside, we're going to get 4X. And that's the part people lose when they do the fake FOIL. And then plus 16, and then minus 3X minus 12. And then from there, we can just combine our terms. So X squared, up 8, down 3, so that should be plus 5X. And then 16 and down 12, so plus 4. Same thing on this, just kind of written the other direction. And so this one, in this case, G is going to be evaluated at F. So I think of it sort of as, here F eats G, so G goes in here. G is going to eat F, so F is going to go into this one. So that's going to look like X squared minus 3X plus 4, pretty much. That would be it, right? Because we're just finding G of X squared minus 3X. So this x squared minus 3x is going in for that x, and then it's just plus 4 on the end. So that's all that one would do. Okay, this one's just another composite, so we're finding f of g of x. So that means we're going to find f of, there's our g of x, x plus 5. So we're going to put a root x plus 5 in for the x. So I'll just slip that down here. So that will look like, and so it's going to have a square, so I'm going to throw parentheses around it. X minus 5, plus 5 squared, and then minus 8. And then here, the square is just going to undo the root, because if you think about, if you have something square root squared, they just undo each other. And so x plus 5 minus 8, and then combining my terms, x minus 3. Same idea over here, just going the other direction. So now we're finding we're going to evaluate g at f. So we're going to evaluate g at x squared minus 8. So that would look like, here's g, so it's a root. This is going in for the x, and then plus 5, and then just those couple like terms. So x squared and minus 3. Okay, and then these last couple of examples, it seems like an odd thing to ask you to do, and if you're learning this to go into calculus, this is such a thing for the chain rule. Like this little skill of being able to spot what's the inside and what's the outside function is a huge deal for chain rule coming up in derivatives. So I would just say kind of go with it, even if it doesn't make sense why I might ask you to do this. So here we're given, we're told that this is our h of x, and we're trying to write it as a composite of f of g. So f's going to be our outside function, g is going to be our inside function. And so looking at this, we're trying to figure out what would I plug into something else to make it do that. And so I almost think this one is easier. Let me do this one. It probably doesn't matter. I'm going to do this one first. So here, it kind of feels like the outside function would be like that. That there would be this root, and then the inside function, what you would put in there, that would be your x minus 6. And so your outside function, your f, would be f of x equals this, and then your inside function, your g, would be that. So then if h of x equals f of g of x, then this would go in here, and that makes your h of x. Same thing over here, just with the fraction. So here our f of x, what we have to plug into, we would need a 7, and then we would need something plugging into that denominator. So I'll make that the x. And then g of x, what will get plugged in, that will be x plus 9. So you can see if I go f of g of x, this goes in for the x, it makes that function.